Think your Express API is well tested? Think again. In this video, we'll dive deep into advanced unit testing techniques for Node.js application, covering best practices, mocking dependencies, and ensuring your API is bulletproof. Hi, my name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. When building an application, our code can be represented as a dependency chain of modules. Module A depends on Module B and C. Module B depends on a library, let's say Axios. Module C depends on Module D, and Module D can also depend on a library such as SQLize. To explore this chain, we can look at two modules in isolation. Let's say one of them is a client and the other one is a server. The client module requests some kind of data and the server module provides it. Testing the server is easy, at least in this isolated case, because it doesn't have any dependencies. But testing client is a bit harder because besides simple state tests that don't require any dependencies on the client, except for maybe standard libraries, we also need to write collaboration tests since the client depends on the server. By the way, if you would like to learn how to write state unit tests, please check out earlier video on mastering unit testing. So, in order to write the collaboration test, we need to answer two questions. On one hand, does the client call the server's methods correctly, meaning the client calls the correct method with correct arguments? On the other hand, does the client handle responses returned by the server correctly? For example, if a client is asking for a collection of tasks and the server responds with only one task in that collection, does the client return back this one task or does it redirect to that specific tasks page? Or what happens if the server throws an error? Does the client handle it correctly and doesn't break? To answer these questions, we don't necessarily need the server. The server can depend on ORM and have a connection to the database. This will complicate the tests, making them slower and database dependent. So instead of the server, we can use mocks and stubs. To answer the first question, we can create a mock. A mock is essentially a server's test double that mimics the behavior or methods of the server. For example, we can create a server's mock that will have create task method. Now we can test if the client calls that method with correct arguments. To answer the second question, we will need a stub. A stub is a hard coding the mocks method to return a specific answer that is convenient to the current test. For example, the client's create task method can return a newly created task. Now we can test if the client correctly handles this newly created task. As an aside, besides mocks and stubs, there is also a spy. A spy in testing is a wrapper around an object that gives information on how this object is interacted with. Unlike mock, spy doesn't replace an object. If you have a repository, a spy won't replace its methods. This repository will still interact with the ORM and database. The spy will give you the information about the interaction, for instance, which methods are called and with what arguments. I tend to use spies very infrequently. For the most part, I use mocks and stubs. Okay, so after the collaboration tests are created using mocks and stubs, there is actually one more thing that needs to be taken care of. When we use the server's create task method, there is also an implied contract. Create task method should return a new task. We stop this return for the client's test, but ideally we also need to be sure that when we test the server's create task method, it actually returns a new task. These contract tests can be hard to write because you will need an actual clean database to make sure the task is created and returned by the server. If you are dealing with a third-party API that you don't have control of, these contract tests may be even impossible to create. In reality, with the third-party integrations, most of the time you will have to assume the contract will be respected. I hope now you can see the pattern here. If the server depends on another module, now the server becomes a client and that other module becomes a server, and you write the state and collaboration test for the new client previously known as a server. And so on and so forth till you reach either a module that doesn't have any dependencies or depends on a third-party library like SQLize that doesn't need to be tested since this library was already tested by its creators and maintainers. Okay, let's see how it looks in practice. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. I am in Node.js Express project. This is a task manager API that we have been building. As usual, the link to the GitHub repository is in the description below. In src routes v1 tasks controller.ts file, we have a function createTask. This function instantiates createTask use case with request and mailer and calls execute method on it. The result is then returned back to the user with the status 201 in JSON format. Let's see how we can test this function. In src test folder, create task controller.test.ts file. In this file, we will import request and response from Express, mailer from services mailer. We will also import create task use case from use cases and create task function, the actual function we want to test, from the controller. Since the create task function depends on create task use case, we need to mock it. We will mock the mailer as well because we pass it to create task use case when instantiating it. Let's describe create task function. In the callback function, let's define rec and res as partial types of request and response types respectively. Execute mock is a mock for the execute method on create task use case. JSON mock and status mock are mocks for the methods status and JSON on the response. This way, we will check if the client is handling the server's response correctly. In our case, if we're setting the correct status and sending the correct JSON back to the user. After assigning the types, let's create before each function and define rec, res, execute mock, JSON mock, and status mock. Rec will have the body and the auth properties. The body will contain the payload for the task to be created. JSON mock is just a mock responses JSON method. Status mock is a mock of a status method that will have the JSON mock chain to it. Execute mock is a mock method that will be called on create task use case. Besides testing that this method is called correctly, we will also need to test if the response from that method is handled correctly. As we mentioned before, we will need execute mock to return a stub. Our stub is a task object with an ID of 1 and the name new task. Since execute method belongs to create task use case object, we will need to mock implementation of the execute method by assigning execute mock to the execute property. Finally, we are ready to write a test. As you may have noticed, you will need to be pretty good at mocking, so be sure to check JS documentation to learn how to create mocks. And as usual, feel free to ask ChatGPT for help. It does pretty good job at mocking. Let's create test function should create a task and return 200 with the task data. Inside the callback function, we will call create task function of the controller with rec and res arguments. Now we will use several assertions. We will expect that create task use case was called with a rec and mailer object. Essentially, we're testing if create task use case was instantiated with the correct arguments. Next, we test if execute mock, aka execute method, was called on create task use case instance. These two assertions make sure we call the methods correctly. Now we need to make sure we handle the response correctly. We will do that by expecting that status mock was called with a 201 created status, and the JSON object has a task property that is assigned to an object with a task ID and a task name. Let's run npm run test to make sure the test we wrote is passing, and it does. Now we need to test the dependency of the create task function, create task use case, and in particular its execute method. Let's take a look at create task use case class. The execute method uses the repository to create a task and the mailer to notify an admin that the task is created. So, to test this method, we will have to mock the repository and its create task method and the mailer and its send method. We will create a stub for the task created by the repository since it is used by the mailer. We will also make send method of the mailer to throw an error to check if it is handled correctly. Let's create task use case.test.cs file in src test folder. We're going to import create task use case from use cases, request from Express, iMailer interface, repository, config, and logger. Next, we're going to mock repository's create task method with a jest mock. We will also mock the error method of the logger to check if it is called if the error is encountered when attempting to send a notification email. Now we can call describe function to describe create task use case. As before, we will mock rec and mailer objects in before each function since we will need them to instantiate create task use case. Let's create a test called should_create_a_task and send an email. In the async callback function, we will first create a stub for task data and make sure repository's createTask method returns it. Next, we will instantiate createTask use case and call its execute method. Finally, we will assert that createTask method has been called with a request body and an authenticated user ID. The mailer is called with an appropriate object, and the result equals to the created task data. In the next test, we will check if an error is logged when an email notification fails. Again, we will define task data and mark it as a response of createTask method. We will also mark a rejection value that mailer's send function returns as an error. Sometimes TypeScript gets in the way of tests, so not to get in the weeds of figuring out what it doesn't like about our test code, we can simply have comments at test expect error above the code lines that cause us problems. After instantiating the createTask use case and calling execute function, we will expect the logger's error method to have been called with a mail error. Let's check if the tests we wrote are passing. This time we will run npm run test --watch to start Jest in watch mode. This way Jest will be watching for changed files. You should be running it this way when developing. Finally, let's write a test for the mailer. Let's open mailtrapmailer.ts file in services mailer mailtrapmailer folder. Mailtrapmailer class uses node mailer library that will need to be mocked. The transporter is initialized in the constructor function. The send method uses the sendMail method on the transporter to send an email created for an object passed to sendMail. Let's create mailtrapmailer.test.ts file in the src tests folder. We will import node mailer, config, mailtrapmailer itself, and iMail notification interface. We will define sendMail mock to return email sent successfully mock. Also, we will mock node mailer's create transport method and assign sendMail mock to sendMail. Let's create describe function to describe mailtrapmailer tests. We will create a new mailtrapmailer before each test, and after each test we will clear all the mocks. Now let's create the test itself. We are testing that mailtrapmailer should send an email with the correct parameters. First, we define mail notification object. Next, we call send method on the mailer with a mailer notification object. Finally, we will do a few assertions. We will assert that createTransport was called with the correct configuration parameters, that the sendMail method, or actually its mock, was called only once, and that it was called with the correct object. After saving the file, JustWatcher detected the changes and reran the new test. Everything is passing. And there you have it. By creating state and collaboration tests as well as contract tests where possible and moving up the dependency chain, you can write a solid set of unit tests for your project. Although unit tests will be the bulk of your project's tests, sometimes you will need integration tests to make sure the components, such as middlewares, work well with the other modules. In this case, Supertest is a helpful library. To learn how to use it in your project, please check out this video next.